In 7.2, we're doing the quadratic formula again. If you remember, we did it when you were in Algebra 1. But now we're going to do it in some of our answers are going to require a lot more simplification. They're going to be kind of difficult. That's why I only gave you 5 of them to do. And I'm just going to do a few of them here. I'm going to do number 3 first. Okay, so here's the equation for number 3, and we know that we need to plug it into the quadratic formula, and I know it's been so long since you heard it, and I know you're waiting to hear it again. Let's sing the quadratic formula song, haha. X equal negative b plus or minus the square root of b squared minus 4ac. It's a minus all over 2a. So if we look at this and we label it, remember my coefficients are the ax, I'm thinking ax squared plus bx plus c. And so my a here is going to be the coefficient of y squared, which is 1. My b, it's supposed to be a plus, my b is a negative 4, and my c is a 13. I'm basically just pulling those numbers off with the signs that go with them. All right, so we just need to plug them in. Let me make a space in the formula for everything. And again, that's a good way to do it because it can keep you from, accidentally messing some stuff up. Okay, so my A is 1, it goes here and here. My B is negative 4, it goes here and here. And my C is 13, it goes here. So if we simplify that, a negative 4 is a positive 4. Then I have the plus or minus the square root. Negative 4 squared is 16. Negative 4 times 1 is negative 4 times 13 is negative 52. And on the bottom we have 2 times 1 is 2. All right, we get 4 plus or minus the square root of 16 minus 52. Let's see, that's going to be 6. It's going to be 46. Is that right? No, it's going to be 36. Negative 36. Is that right? 16 minus 52. 36 and 16 make 52. Yeah, that's right. Okay. So now, when I go to take the square root of negative 36 is 6i over 2. But that will reduce further because you can divide a 2 out of all of those numbers. That's the fast way to do it. Another way to do it is to say it's 4 over 2 plus or minus 6i over 2 and then reduce each fraction. Well, 4 over 2 would become 2 plus or minus, and then 2 goes into 2 once and 2 goes into 6 3 times. We get 2 plus or minus 3i. Those are our solutions. Remember, that's two solutions. One solution is 2 plus 3i. And another solution is 2 minus 3i. But it's faster to write it the way that I did when I circled it. Remember that the solutions are called our roots. We sometimes call them our zeros because they tend to be our our x-intercepts, except in this case, because it's an imaginary number, it means we don't even have an x-intercept in this case. Okay, number 11, we're also supposed to solve this equation using the quadratic formula. So I've gone ahead and I've written the quadratic formula over there. I've just left spaces for the a's, the b's, and the c's, okay? Now, before I can do that, I got to get this in the form ax squared plus bx plus c. The directions remind me of that, but if they hadn't told me that, I'd still need to do that because if you remember, when we factor and we use the quadratic formula, both of those instances, we have to get all of our terms on one side and 0 on the other side. So that's what I would have to do, even if they didn't give me those instructions. So let's go ahead and do that. 2x times x is 2x squared. 2x times 1 is 2x. Then I got equals 7. Okay, so now let me get the 7 on the other side with all the other terms. I'll subtract it from both sides, and that'll give me the 0 that I want on the right-hand side. And that's 2x squared plus 2x minus 7. Now, if I go ahead and I label that ax squared plus bx plus c, just to remind you where those a's, b's, and c's are coming from, I can see that the a is that 2, that's that coefficient. The b is the coefficient of the x term, which is also a positive 2. And my c here is negative 7. It's the constant term. So that's what I'm going to be plugging in. So my a's go here and here. My b of 2 goes here and here. And then c is negative 7 goes right over here. See if I can make it look like a negative 7. So now I just have to simplify that. All right, so it's negative 2 plus or minus the square root. 2 squared is 4. Now, negative 4 times 2 is negative 8, and negative 8 times negative 7 would be a positive 56. And on the bottom, we have 2 times 2 is 4. Okay. So now, let's see what we have. Under the radical, 4 plus 56, we know that adds up to 60. So I know I got to simplify the square root of 60. Well, now let me come over here to do that. The square root of 60 is, let's see, if we prime factor that, that's 6 times 10, right? Well, let me go ahead and just write in little steps here to show you what I'm doing. 6 is 2 times 3. 10 is 2 times 5. Oh, I could pull a 2 out because there's 2 copies. And then I would have 3 times 5 is 15 left inside. So that whole square root of 60 over there, it simplifies to 2 square roots of 15 over 4. Okay, now if you look on the numbers on the outside, I could divide a 2 out of all of them. So that's what I'm going to do. That's the fast way to do it. All right, so negative 2 divided by 2 would be a negative 1. 2 square roots of 15, if I take that 2 out front and I divide it by 2, it would be just a 1 square root of 15, so I won't write the 1 down. And then 4 divided by 2 is 2. So this is what my answer is. There's actually 2 answers. One is negative 1 plus square root of 15 over 2, and the other one is negative 1 minus square root of 15 over 2. And the book may even do this. Sometimes they split it up and say, well, that's negative 1/2 plus or minus the square root of 15 over 2. They put that denominator with each part of the numerator. So either way, whether you write it, either way, it's still the same thing. Anyway, that's all I'm going to do. You only had 5 to do, and most of the time it's just issues with simplifying, and people make lots of little mistakes. So if you don't get exactly the right thing, backtrack over your work and try to figure out where you went wrong. It's always just a simple math thing. And if you can't find it, make sure that you're doing what I'm circling up here in yellow, that you're writing these parentheses this way, because that's going to help you catch a lot of your errors. If you don't do it and you ask me to look at it, I'm going to say, well, why didn't you put your parentheses in? Because honestly, that's how I avoid making as many mistakes. So it's a good practice.